Okay, so with the chain rule, we use it to derive a composite function, which is a function within a function, and we introduce a new term u and let it equal to the internal function. So this is it here, and it's probably easier to remember what to do without thinking of the u's and the v's and things like that that are written in the tables book. I'm going to talk through it by using an example. Let's say we have a function y is equal to 4x plus 3 to the power of 3. Well, our internal function here is just 4x plus 3, and the overall function is 4x plus 3 all to the power of 3. So what we're going to do is we're going to introduce the u, and we're going to say let u equal to 4x plus 3. That just means that y now equals u cubed. And if we're asked for dy dx, well, that's just going to be equal to dy du, which is the derivative of y with respect to u, i.e. deriving this function, multiplied by du dx. So the derivative of u with respect to x, which is this part here. So that part is there, and that's what this part is. So if we first look at dy du, well, dy du is just the derivative of y with respect to u, so it's going to be 3u squared, and we're multiplying that by the internal function du dx, which is here, so it's the derivative of that, which is just 4. So overall that becomes 4 times 3u squared, which is 12u squared. We're not quite finished because u wasn't there at the start, we introduced it, so that is just going to be 12 times 4x plus 3 all to be squared, and that's what the derivative of our overall function y is equal to. So if we think about it, y was just this thing called 4x plus 3 all to be cubed, and the derivative then became 12 times 4x plus 3 all to be squared. Another way of thinking of how to apply the chain rule is just to pretend what's inside the brackets there is just an x and just derive that. So if that was just an x, that would be x cubed. We derive that, that's going to be 3x squared, and we multiply that by the derivative of what's inside the brackets, which is 4x plus 3. So using the chain rule, you derive the overall function and multiply it by the derivative of the internal function. So the overall function derivative is going to be 3 times 4x plus 3 squared times the derivative of the internal function, which is 4x plus 3. So we're multiplying that essentially by 4. So it's going to be 12 times 4x plus 3 squared. We're now going to look at a different function called y is equal to cos of 3x, and we're going to derive this. We're going to have to use the chain rule here because we do have an internal function here. It's not just x, it's cos of 3x. So what we're going to do, we look at the derivative of cos in the tables, and that's minus sine. And what I said in the previous sum was that what we do is we derive the overall function, almost pretending that the internal function was just an x, so the derivative of cos is just minus sine, so it's going to be minus sine of 3x, so dy dx equals minus sine of 3x times the derivative of the internal function. Well, the derivative of 3x is just 3, so it's going to be times 3. So overall that is just going to be equal to minus 3 times the sine of 3x. So I'm just going to go through this table now in a little bit more detail. In the tables, this is what you're going to see. First off, we have differentiation by rule. Then we've got some of the other functions that you come across in leaving cert question. So the natural log of x, the derivative of that is just 1 over x. The derivative of e to the x just becomes e to the x. It's the same thing. The only difference is when you have e to some number times x, then the derivative of that is just that number times e to the ax. Sine, cos and tan, derivatives of those come up quite a bit, but they are in the tables. And the inverse trigonometric functions don't crop up too often, so we're not going to worry about them. Here's your product rule, chain rule, quotient rule. Okay, so I've gone through 3 of the rules, the product rule, the quotient rule and the chain rule there, and also just differentiation by rule. It's worth practicing as many of the sums as you can in those in order to stay on top. Look through the past paper questions and you'll see how to become more familiar with them. So we're now going to look at a past paper question that came up in 2016. The question is, if y is equal to x times sine of 1 over x, find dy dx, so the derivative of that. So what we're going to be doing here is using a combination of the product and the chain rule. Product rule first tells me that I need to multiply the first term x by the derivative of the second term. Well, for the second term, we have the sine of 1 over x. Well, as that's not just sine of x, that is an internal function. So what I'm going to do there is use the chain rule to derive sine of 1 over x. And I'm going to do that in a little bit of detail here. The sine of 1 over x can also be written as the sine of x to the power of minus 1 using our indices. And whenever you're asked to derive x to the power of minus 1, okay, the derivative of x to the power of minus 1 will be bring that to the front and then drop the minus 1 down by 1. The derivative of that on its own is going to be minus x to the power of minus 2, which is equal to minus 1 over x squared. That you'll come across that quite a bit. Whenever you have a function like 1 over x or 1 over x squared, you need to be able to convert it into its indice form, which is x to the power of minus 1. Then you can bring that power to the front and drop the power down by 1. By dropping minus 1 down by 1, it actually becomes minus 2. Reverting that to its normal form, then x to the power of minus 2 is just 1 over x squared. So I've just moved that out of the way. So the derivative of sine of 1 over x, using the chain rule, it's going to be the derivative of, let's say, sine of x, which was here. So it's going to be cos. So that's going to be cos 1 over x, because that's what the derivative of sine of x. But we need to multiply it by the derivative of what's inside the brackets, if you remember the chain rule. And the derivative of 1 over x, as I've just worked out there, is minus 1 over x squared. So the derivative of sine of 1 over x is actually minus 1 over x squared times the cos of 1 over x. So we're just still using our product rule now. We've just used the chain rule to derive that. Well, the product rule also states we need to add on, I'm just going to do that here, plus it's going to be the second term, which is sine of 1 over x, times the derivative of the first term, which is times the derivative of x, which is just 1. So if I tidy all of that up, dy dx is going to be x times minus 1 over x squared. Well, here, that x cancels with that x squared to leave it as minus 1 over x times cos 1 over x plus sine 1 over x. And that is the derivative of that function. Okay, so practice a few more of those, look at the past paper questions and have a look through them.